So yeah, this is the typical tabletop Stirling engine, wherein you can see there is a hemisphere around here, which indicates that the volume is low, minimum. So you can see two pistons in this setup, wherein the one is in the downward. As you can see, I can move this up and down, and the other one is just perpendicular to the opposite piston. So basically the Stirling engine has these two power pistons with a quartz tube covered. So this quartz tube contains two airlets, one as the hot end and other as the cold end. So here we'll be inserting the thermocouples. As you can see, I have just inserted the thermocouple one here. So this will be my T1 and the other one will be considered as T2. So why this thermocouple? And thermocouple we are using here is chromium nickel thermocouple, and this will give me the temperature difference. So before you start off the experiment, you need to calibrate the system. So that calibration will be done using the PV&T measuring unit, as you can see here. So this will give me the values of N, that is revolutions per minute, and T1, which is our initial temperature, T2, that will be a final temperature, and delta T will be the temperature difference. So for engine to work efficiently, we need to first calibrate and maintain the temperature difference, so that then only we can expect the engine to start working. So yeah, so now I'll show you how the temperature calibration is done. So as I said, we'll start with the temperature calibration. So this will be done using PV&T measuring unit, wherein you can see these thermocouples have been connected to this PV&T meter, T1, T2, and then here you can see oscilloscope unit, wherein this P indicates the pressure and V indicates volume. It is given to channel 1 and channel 2. Generally pressure will be going to channel 1, and volume cable will be going to channel 2. So this is the basic connection, and also you can see here PVN, which is directly given to the Stirling unit. So yeah, moving on to the calibration part. So yeah, calibration of temperature is important to make the engine run efficiently. So once the calibration is achieved, then only you can see the engine starts working. So how do you go with the calibration is that here you can see a calibration part. There you can see delta T and V. So you should press the delta T button, wherein you can see 0 T, that is 0 time. Okay, and then you need to click on the volume button, wherein you can see the temperature difference delta T as 0 and T2 is your 36.5 degrees centigrade. So how do you see the T1 value? You just have to click on this delta T again. Okay, and there is a toggle switch. You can see the actual temperature difference, T1 and T2, and delta T you can calculate, or else you can even see from here. Okay, so now delta T is now 0 degree. So that means your temperature calibration part is done. So now once the temperature calibration is done, we also have to calibrate the pressure. So volume is already been calibrated by the manufacturer. The value is being given, the standard value is being given. So you will be using it in the calculation part. So now I will be showing you how the pressure calibration is done. So for pressure calibration, we will be using this syringe. So there is a small pipe given in this Stirling setup, so into which I will be inserting this syringe. So what is the purpose of this pressure calibration is that you will be noticing that you will be getting the values in terms of voltage, because you will be observing everything in oscilloscope. So for pressure calibration, so you will be using this method. And now as you can see, I am now holding this syringe to a maximum volume, that is 20 ml. And now you can see that in oscilloscope you can see the voltage changing, V1 and V2 you can observe. There is a voltage change in this. So you can see here, now it is 20 ml. As I move, as I compress it to say 15 ml, so you can see, you can notice the voltage change here. So it was initially 1 point something volt and now it is 2.3. So that you should do it for both compression and expansion as exercise. So you will be getting for whatever volume you will be giving for atmospheric pressure, you will be assuming it as ideal gas equation, and you will be using that PV equal to P1 V1 equal to P2 V2 formula, and then you will be getting the values of pressure and voltage and volume you will be getting from this whatever value you are giving. So basically now you got whatever pressure, for whatever pressure you are observing, so that will be in terms of voltage. So it will be useful for later exercises which you will be doing, and for now your pressure calibration will be completed using this method. So now you will be coming to the actual exercise part. So till now you were dealing with the calibration part. So since it is pressure and temperature calibration is over, now we will come back to the first experimental part, that is you will be measuring, you will be finding out the thermal power of the burner. So this is the burner wherein you have ethanol in it. So you will be igniting it at one end of the engine, Stirling engine. As I told earlier, this will be your hot tank where you will be supplying heat. So you are supplying heat, and here it will pass this heat to other end, that is cold end, and then it makes engine to start working when it reaches certain temperature difference. And then you can observe the whole PV diagram of Stirling engine in this oscilloscope by switching on to the XY mode. So when you switch it on to XY mode, when you just give a slight push to this engine, you can see it is making a path of that Stirling PV diagram. When you actually as I told, when you actually ignite it and when it reaches to certain temperature, say we will be observing that it's around 60 degrees. So then you can see the actual PV diagram, which I will be showing you in the next part. Yeah, now you can see that the temperature difference delta T has reached 60, it is going on. So I gave a slight push to engine, so it started rotating. So you can see that the N value will is reaching maximum, and when it reaches 900, so we will be taking out the burner, then we will be recording the data. So now you can see that it is just for a slight push, the engine is has started working efficiently. So this is the major advantage of the Stirling usage, and you can even use it as use it for several applications like solar cell to produce the electrical output, so which we will also be doing in the next part. So now you can see how nicely this engine is working. So you can actually now see the PV diagram of Stirling engine in the oscilloscope. As I told, it has reached a maximum N value, that is now I have taken out the burner since it has reached 900, and now you can see the PV diagram of Stirling engine. You can you can observe here in this PV diagram there is a small path here across this, and there is a large cycle here, this space here. So it means that the Stirling is regenerative, which means whatever work is being given out here will be completely used in this phase. So that is why the Stirling engine is a regenerative process, wherein no work is wasted, because the work given out here will be used here, and it repeats when till it reaches the temperature, minimum temperature. So this is the next part of the experiment, wherein you have to find the electrical power output of the Stirling. This is the given circuit diagram as given in the handout. So this is the rheostat of 20 ohms, and now this will be your ammeter according to the given connection, and this is your voltmeter. And here everything is given to the generator setup. So this is the generator unit, which is now in the motor mode. While doing the experiment, you will be switching it on to the generator mode. And now there is a strap wheel which will be used as a mechanical arrangement, and with given a slight push again while using the same technique as we did before using the burner, we will be observing the PV diagram, and then again we will be noticing the change in the voltage and current values accordingly.
So this is your load resistance, this is your ammeter, and this is your voltmeter. Fine. Now once you turn on the generator, I'll just give it a push. Now you can note down your current and your voltmeter reading. Okay. Now you don't have to worry about the resistance, as this will give you the resistance of the whole circuit. So you don't have to worry about that now.